All right, so as I've been really kind of helping prepare you guys for the past week here, we're going to go into piecewise functions. So I'm going to start off here just with a quick definition. So piecewise functions are they are made up of two or more functions, usually two to three, for what we're going to be doing, but they can go beyond that. But each of those pieces is going to have its own domain, and that's going to be really the key today. Is just going to be recognizing the domain of each piece, because that's going to determine how we evaluate and how we graph them. So to get us started here, we'll start with just the evaluating piece, and we'll move on to graphing. So number one, notice the domains for each one of these pieces of our piecewise function. And each piece represents a different part or a piece of a function. And again, it's not the whole thing, but it's just that piece of it. So for example, the absolute value is only valid when x is less than -3. If x is greater than or equal to -3, we don't have that absolute value function anymore. We have another piece that we're going to be evaluating. And again, that domain will tell you. So for instance, A, we have f of -5. That's going to be that first piece, the absolute value piece, because -5 is less than -3. So that's going to equal 2 absolute value of -5 minus 5, which is 2 times the absolute value of -10, which equals 2 times 10, or 20. If I can write that right, there we go. But we move on to f of 2, and you'll see that 2 lies in that middle function, that middle piece. So it's going to be a part of that quadratic function. So we're going to plug that in for the -x squared function. So -2 squared plus 4 times 2. And again, notice how I did the parentheses around the 2, because that, based on order operations, since there was no parentheses around the -x, that means that I'm squaring the 2 first and then applying the negative. So it's going to end up being -4 plus 8, which is 4. And finally, f of 7. Again, 7 is greater than or equal to. It is actually equal to 7. So the 7 goes into that domain, which means we're plugging into the square root function. So we're going to plug into the square root of 2 times 7 plus 6, which is the square root of 14 plus 6, or the square root of 21. And again, if we're graphing, you might need the decimal, but for evaluation purposes, there's no real reason to go ahead and get that decimal. So we're good at that point. Moving on to number 2. Same thing here, just pay attention. It may not always go in order when we go to evaluate, because see this -3 here for g of x. Well, the -3, that's going to show up in that middle domain. -3 is in between -4 and -2. So in this case, we just get a constant. There's nowhere to plug in -3, so that's just going to be 8. Those are actually the easiest ones you can probably have, because no matter what you're plugging in there, you're getting 8. That represents a horizontal line. That little piece right here is y equals 8. It's a horizontal line. It doesn't really change no matter what x is. You plug in -8. -8 is less than or equal to -4, so we're going to plug it into that cubic function. So it's going to be 1/2 times -8 to the 3rd power plus 7. So again, in this case, all we need to do is bust your calculator out to figure out the -8 cubed times 1/2. So I'm doing that actually right now on my calculator. But so here we go. We got 0.5, and then it's -8 to the 3rd plus 7. So in this case, I'm going to get -249. And lastly, we have g of 3.1. And again, we're plugging in 3.1. It's going to go in right here, because 3.1 is greater than or equal to -2. So that's going to go in our step function. Hopefully you know how to use the step function so we can evaluate that. So that's going to be 3.1 minus 4. Well, 3.1 minus 4, that's -0.9. And remember, we always round that down to the next integer down. So in this case, since it's negative, it's going to become -1. So that's basically evaluating piecewise functions. Just make sure, again, you pay attention to that domain, which is going to be a theme that works its way into the graphing. So when we go into graphing, before I kind of go through this process, there's one new thing we're going to talk about. I'm going to talk about types of discontinuities. And there's two types that we're going to be dealing with here. So I'm going to kind of set that up over here. The first type is called a jump discontinuity. And a jump discontinuity is just when you have a point and another point, where it jumps. So there's a gap. I kind of drew that wrong. So we have a gap in your graph, and it jumps from one point to another set of values. Think of it this way. If I'm using my pencil to draw this graph and I just jump from this point to this hole to start the rest of my graph, I'd have to pick my pencil up off the paper. So I'm jumping from one point to another. So that's going to be called a jump discontinuity. It's a break in your graph that represents, again, a new function, really, a new piece of my function. The other type is called an infinite discontinuity, and we actually deal with these in other situations, so it's going to be kind of similar to that. But this is where you have, say, an asymptote in your graph. So let's say I'm drawing and I'm going up to infinity, and I'm going down to negative infinity. Say this is a a rational function. This, even though there's some other pieces that are in there, this right here represents an infinite discontinuity. So basically like a vertical asymptote. So if you don't have a vertical asymptote and you're just jumping from one point to the next, this little gap right here, that's a jump discontinuity. That's what we'll have most of as we do these piecewise functions. But if we're graphing one that has a vertical asymptote, we have an infinite discontinuity as well. So when it says identify the location and the type of any discontinuities, that's what we're talking about. Is it a jump or an infinite discontinuity, and where is it? So here we go. Number 5, we're going to start with that. And the process we're going to do on these for each group or each piece, so I'm going to color code these. For all my pieces, the strategy I like to use on these is I like to find the starting point. So I'll say start and my ending point. So start and end. And that's just my shorthand because I don't want to write starting point, ending point every time. But your graphs, they're pieces of graphs. So look at your domain, and usually if you're on the ends of these pieces, one of either the starting or the ending point is it's just going to be infinity. I don't even recognize if it's a negative or positive. Well, as soon as I say infinity, that means I'm going to draw the whole thing on that side. So my starting point in this case, notice when I say starting and ending, I'm going from left to right. So as you go to the left, you'll notice on this first piece, my domain is x is less than or equal to 1. So it goes left forever. So I don't really have a true starting point. It just goes left forever, so infinity. However, I do have an ending point. My ending point is going to be at x equals 1. So I want to figure out what that y value is for where this ends. So you do that by plotting. I'm going to plug in 4 over 1 plus 3. So that's going to equal 4 over 4, which is 1. So my ending point is the point 1, 1. So on my graph, I'm going to plot just a piece of this. Again, we're graphing when x is less than or equal to 1. So I'm going to start with the point 1, 1. And if you know this graph, understand I'm only graphing it to the left, but you still want to know what the whole graph looks like. So I know with this graph, I have a vertical asymptote because I'm going left 3 at negative 3. And this is that piece where, why we've been going over graphing these for the past week, so that you can understand what I'm doing right now. Okay. The next thing you would probably want as well is to figure out the y-intercept on this graph. So if I was going to do the y-intercept, that's when you plug in 0 for x, so that would be at 4/3. So I'm going to plug in a point at 4/3, which is just over 1. And remember, this graph does not go any farther to the right, so I can just go ahead and graph this to the left, and I'm going to go up to infinity. Now, the next thing you want to realize, there's no vertical shift. It's like plus 0, right? So what that means is that my horizontal asymptote is going to still be at 0. Now I'm only going to draw that horizontal asymptote up to x equals 1 because after that we don't have a rational function anymore. So this graph is going to be down here. It's going to come up and it's going to go off to negative infinity. It's going to approach 0, but as x goes to negative infinity. So that is the left piece of your graph. Remember, we're just not drawing this extra little piece out here. That's all. Okay, we have a new graph that goes on that part. So I'm going to draw that second piece. So this second piece is just a line. So that's actually not so bad. But again, it has a starting point and an ending point. So start and end. So on this one, our starting point is going to be an actual point because we start at 1. So I'm going to plug in 1 and figure out what y is. So that's going to be 2 times 1 minus 7. 2 minus 7 is negative 5. So I have a point at 1, negative 5. Now as I go to the right, it's going to go to the right forever, so I'll just put infinity there and we'll be good. So I'm going to plot the point 1, negative 5, but be aware on this one, it says greater than. So it is going to be an open circle, not a closed circle on this. So I'm going to go to 1, negative 5, open circle, and this is just a line, which in this case is actually going to be a ray because I'm only graphing in one direction. So the slope is 2 over 1, so I'm going to go up 2, right 1. You can follow that pattern here until you just get your line and draw it. And that is your piecewise graph. So as I go ahead and label all this, I'm going to start with my domain. So my domain in this case is going to start at negative infinity. We do jump over that vertical asymptote, so I'm going to jump over the point negative 3. Then I'm going to go from negative 3, and notice there is a jump discontinuity right here, but if you really look at the actual domain, it doesn't really it doesn't really skip a point. I mean, I have a circle here, yes, or I have a hole down here, yeah, but that hole is filled by that other point. So my domain is just going to keep going all the way off to infinity. So it's negative 3 to infinity. I only have to jump over that vertical asymptote. So in this case, my range, if you look, the only issue that may occur is this horizontal asymptote here, but notice that point is filled as well with my other piece. So my range is actually going to be all real numbers. So the last thing to really recognize on this is that you do have discontinuities. There's actually 2 of them. The first one is x equals negative 3, and that is going to be that infinite discontinuity because it's an asymptote. The other one is that jump discontinuity. So here it's going to be x equals 1, and we call it a jump discontinuity because I have to lift my pencil to keep drawing. But it doesn't affect my domain, as you can see. So that is number 5. That's a basic piecewise function. We have 2 more I'm going to walk through with you guys here. So let me go ahead and do that now. All right. So for this one, again, I have 3 parts. So I'm going to start with blue, because I was already with blue there. So when we do number 6, again, we have a starting point. So I'll say start and end. So on this one, the starting point is going to be infinity because it goes off to the left, but my end point is x equals 4, or negative 4. So we're going to plug that in and see what we get. So that's going to be 3 times negative 4 plus 8. Negative 12 plus 8 is negative 4. So I have a point negative 4 in my graph. So when I start this one, I'm going to plot the point negative 4, negative 4. Pay attention when you graph it. It's less than or equal to, so it will be a closed point. So I'm going to go to negative 4, negative 4. And this one has a slope of 3, but I have to go backwards, so I'm going to go down 3, left 1, as opposed to up 3, right 1. If I did up 3, right 1, notice it would still fit, but we only graph this to the left because it's x is less than or equal to negative 4. So I'm going to go backwards on that one. So there's my first piece. The next piece, I don't have to really do any work because that, as I said before, is a horizontal line. So the starting and the ending point is going to be at negative 1. So I'm going to go negative 4, negative 1, open circle because it's x is greater than -4. And then the closed circle on the second point because it's less than or equal to, so I'm going to go to 2, -1. Horizontal line, go ahead and draw it. Again, those are the easy ones. You kind of wish you have more of those because they're so simple. And the last one, we're going to do the x minus 2 quantity squared minus 5. So for this, my starting point, I want to label. So start and end again. Now the ending point on this is going to be infinity because it goes off forever, but my starting point is at 2. Now, if you notice, 2 is where your vertex is. So you can kind of see it's at 2, -5 because that's your vertex. You notice this tells me I'm going right 2 already. You can also plug in 2. Notice you'll get 0 squared, but this is a little faster. So my vertex is actually where this graph begins. If you recognize the functions and you see that, you'll notice that. So I'm going to go to 2, -5. Again, put an open circle here. So 2, then down 1, 2, 3, 4, 5. 2, -5 is right here. And again, that's your vertex. Now, let's say I knew my vertex was there. Then I would know my graph would look like this. But this is my vertex. So I know my graph is just going to go up from here, and we're going to draw it at that point. So that's going to be your piecewise graph. Now again, all we need to do is get our domain. Now again, just like before, wherever there's a break in my graph, notice that hole is getting filled by that point, by one of those 2 points. Wherever there's a hole, there's a filled in hole either below it or above it. So my domain doesn't actually get broken up. So your domain on this is going to be all real numbers. Your range, we're going to have a similar situation here as well. Notice it goes down forever and it does go up forever. Now you want to see, is there a break in between, like some sort of gap between your graphs? And if you look at it, it's not happening. So there's no gap at all on your range, so your range is all real numbers. And then lastly, we have, again, 2 jump discontinuities. You'll notice the first one is right here. The second one is right here. So that's going to be at 1, 2, 3, -4. And we have the other one at +2. And again, both of these are going to be jump discontinuities. So just say jump and they're fine. All right, so there's your second piecewise graph. We got one more to go. So we're going to jump down now and do that. So here, I'll start the colors over. Actually, I'll pick some different colors in this one. So we'll start with pink. All right. So on number 7, we start this one off with a nice little horizontal line. But be aware, this graph is only present when you're going left from -1. So I'm going to go to -1, 7. I'm going to put an open circle at -1, 7. And again, this is a horizontal line going left. So it's like, actually in this case, a ray. So I'm going to draw a ray going left. There is your first piece. The second piece is going to have a starting and an ending point. So I'm going to go ahead and do that now. So this is going to be in light green, I guess. So again, we got a starting point. So start and end. So this one, again, has both because we are in the middle on this one. So I'm going to have to pick that starting point at -1 and evaluate. So that's going to be -1 cubed. Now this one, again, I'm plugging -1 into the function, so it's -1 quantity cubed, although it won't matter here, -1. So that's going to be -1 minus 1, or -2. So this graph starts at -1, -2, and then it's going to end at x equals 2. Again, I'm just looking at my domain here if you're wondering where I'm getting those numbers from. So I have y equals 2 cubed minus 1, which is 7. So let's go ahead and plot those points first, and then we need to kind of visualize this graph a little bit. But I'm going to go -1, -2 first. And again, that's going to be a closed circle because its x is greater than or equal to. And actually, it's both of these are closed circles, so my next point at 2, 7 will be a closed circle. So closed circle right there. And again, notice this graph, if you zoom in a little bit here, this one is going down 1, which means that point 0, 0, which is normally the center of your curve, is now at 0, -1. So I'm also going to put that point in there. And if you want to test the x-intercept, it's going to be at 1, 0. You can see the symmetry with this. It is symmetrical. So I'll just get that point as well. But again, this graph is flattening off here because that's the center of your curve, and then it starts to curve up from that point. And there you go. If I drew the whole thing, it would just look like this, but we're not drawing the whole thing. We're only drawing that piece of the graph. And that leads us into the final portion of this graph. I'll do that in dark purple because I don't use that one very often. So this one is going to be a radical function. We've got a few things going on here, but first thing I want to do is find that starting point. So that starting point is at 2, so I'm going to go ahead and find that. And again, the ending point is just infinity, so I don't need to worry about it. It's just going to go off forever. So the starting point is, again, x equals 2, and then what is y? So this is going to be negative square root of 2 times 2, which is 4, plus 1. So that is negative 2 plus 1, which is negative 1. So my starting point is at 2, negative 1. So I'm going to plot that point. Okay, and again, notice I put the open circle there. Now, with this graph, a couple things that we know. First, this is going to be flipping over the x-axis, so I know it's going to go upside down. So that's one point that I'm aware of. And second, this is a vertical stretch. So we want to show that. And then plus 1 means that we're going to go up 1. So if I was doing this graph originally, I'd be going up 1, and it's just going to be stretched like this. But again, I'm graphing it from this point. So my graph is basically going to look like that. It's just that little chunk of the curve. So it's just going to kind of do this for the most part. But we want to kind of have it fit. So to see that stretch, what we're going to do is we're going to just pick a point to help us see this. I got to get rid of that because I'll need that for the domain later. So I'm going to just pick a random point. I will pick, and I don't know where I'll do it. I don't have much room here. Let me just squeeze it in here. So I'm going to use the space. I'm going to pick a point on my graph. Now I'm currently at, well, I'm at the wrong point, but I'll fix that. I'm currently at 2, 2, negative 1. I did 1, negative 2, but I'm fixing it. So 2, negative 1. So I'm going to pick a point maybe a couple spaces beyond that just to see this. I'm going to pick a point at 4 and see what I get. So this will be x equals 4. So y in this case will be negative, and then 2 times 4 is 8 plus 1. So again, I don't care if it's a decimal, it's not a big deal. So we're going to have the square root of 8, I mean a negative square root of 8, but you know, same difference. And then I'm going to take that and add 1 to it, and on my calculator it gives me negative 1.83. So I'm going to go to the point 4, negative 1.83. That allows me to see that stretch, and it actually confirms again if my graph's upside down and all that stuff too. So I'm going to go 4, negative 1.83. So 1, 2, 3, 4, negative 1.83 is just about right there. And it may seem like you think it should go down farther because it's being stretched, but understand it's already coming from up here. So it's actually come down pretty fast. And remember, no matter what, it eventually levels off. So we're just drawing that leveling off portion of the curve. So we're good. It looks like this. So that is the last piece of my graph, and we just have to wrap this up with our discontinuities and our domain and range. So again, domain, as usual, we have yet another one with a domain of all real numbers because all those points are getting filled. The range, if you look here, this graph does go down forever, but it doesn't go up forever. It's not going up forever. So my range is not going to go to infinity. It does start at negative infinity though. So we have negative infinity, and it stops right up here, and that was at 7. So that's as high as this graph will get. It will touch 7. So we'll put a bracket next to that 7. Please put those brackets there. And lastly, we have 2 jumps in my graph. So we're going to take these 2 points and make sure that we call those our jump discontinuities. So that's going to be x equals negative 1 and x equals 2. And again, they're both jump discontinuities. So that is piecewise functions. Hopefully that makes sense to you, and good luck on your homework for it.